Hello and welcome to this video on straight line graphs for the A-level syllabus. This is a topic that you would have been introduced to back in your GCSEs, so we need to make sure that we master it before moving on to some of the harder algebraic topics such as circles or even calculus. Before we start, can you remember what the equation of a straight line looks like? Well, the equation of a straight line is y equals mx plus c, where m is the gradient and c is the y-intercept. To understand what these are, we're best to think graphically. Now, as I said, this is the equation of a straight line, so we can draw that here. Firstly, we can think of this m, which is our gradient. The gradient is a measure of how steep we are, and we can work this out by working out how far we go up by how far we go across, or our change in y coordinates divided by our change in x coordinate. And c is our y-intercept, so this is just where we cross the y-axis. Let's do an example. In this question, we're going to be given a straight line on a set of axes. We're being asked to find the equation of the straight line. Firstly, I'll start by finding the gradient. Let's pick any two coordinates along our line. We need to work out how many points we go across and how many points we go up by. In this case, we've gone from 2 to 4 on the x-axis, so we've gone up by 2. We've gone from 6 to 9 on the y-axis, so we've gone up by 3. The gradient, m, is just the change in y, 3, divided by the change in x, 2, so it's just 3 halves. The y-intercept is much easier to work out. We can just look at our y-axis and look at where the line crosses. In this case, it's 3. So the equation of our line is y equals 3 over 2x plus 3. In A-level maths, we learn a new form for the equation of a straight line. Let's derive it. Imagine we have a straight line with gradient m. We only know one point on the line, and we're going to call its coordinates x1 and y1. We're going to write a generalised point on the line, and we're going to call its coordinates x and y. We can then work out the gradient by working out the change in x and the change in y. We therefore get an expression for m, which equals y minus y1 divided by x minus x1. Timesing through by x minus x1 and rearranging yields the following equation. This will be useful in a problem where we're given only the gradient and one coordinate. Let's see this in an example. Find the equation of the line with gradient 6 that passes through the point 3, 5. So in the exam we could spot that we've been given a gradient and one coordinate only. So we'd think about writing our equation in this form. So into our equation we can plug m equals 6, x1 equals 3 and y1 equals 5. By expanding the bracket and then rearranging, we can get our equation in terms of y equals mx plus c. Our answer will be y equals 6x minus 13. Now this isn't the only way you could have answered this question, so if you got to the answer another way, that's fine. This method just gives you a quick way to get to the answer. We're now going to take a look at parallel and perpendicular lines. Parallel lines are just sets of lines that go in the same direction, so they never touch. The key here is that they will have equal gradients, so m will be the same for all parallel lines. So from the axes on screen, if L1 and L2 are parallel, M1 and M2 will be equal. Perpendicular lines are a bit different. They are going in different directions to one another. So if we have two lines, L1 with gradient M1 and L2 with gradient M2, and we're told that they are perpendicular or at right angles to one another, we can write that one gradient is the negative reciprocal of the other, or m1 equals minus 1 over m2. Let's see this in another example. A line is perpendicular to the line 2y minus x minus 8 equals 0 and passes through the point 5 minus 7. Find the equation of the line. Start by taking a moment to consider the key information that we've been given. These will give us the clues as to how we'll begin. We should start by taking the equation of the line given. If we write this in the form y equals mx plus c, we can see what the gradient of this line is. This will help us to work out the gradient of the perpendicular line. So, after rearranging this equation, as I've just done on the screen, you should see that the gradient of this line is 1/2. If we want to work out the gradient of this perpendicular line, we will need to consider the negative reciprocal. So if we do minus 1 over 1/2, we'll get minus 2. So now we know the gradient of our perpendicular line. We need to finish off by working out the y-intercept, c. How can we work this out? Well, we've been given a coordinate that this line crosses, 5 minus 7. We can plug these numbers in and rearrange to find that c equals 3. So we've worked out the final piece of our puzzle. We have our final straight line equation, which is y equals minus 2x plus 3. Let's plot both of these lines so we can visualise the problem. Pause the video and try and plot both of these lines yourself. Now on normal graph paper you would see that these are quite clearly perpendicular lines. Now my axes are a little bit off so they don't look that perpendicular. Now that brings us to the end of this video on straight line graphs. Leave a like and subscribe, and I'll see you in the next one. Thank you, bye bye.